Welcome to the deep dive. Today, we're taking a break from the usual headlines, all that stuff that feels so urgent right now. You, our listeners, have pointed us towards something much bigger, much grander.
Yeah, it's almost hard to wrap your head around.
Seriously, we're diving into the Wikipedia page on the timeline of the far future.
And we're not talking about, like, what gadgets will be cool in a few years.
No way! We're going way beyond. Thousands, millions, even trillions of years into the future, timelines that make all of human history look incredibly brief.
It's amazing what this page pulls together. I mean, think about it. Astrophysics, the study of how stars live and die.
Right. And particle physics, which zooms in on the tiniest pieces of reality.
Not to mention geology, the slow, steady forces that shape our planet.
It even touches on how life itself might evolve over these unimaginable stretches of time.
And the key here, which the page makes very clear, is that we're not dealing with guaranteed predictions. The future, it's always full of surprises.
Absolutely. But what this timeline gives us is a kind of what if, based on our best science. If the laws of physics keep working the way we understand them, if the processes we observe continue on their course, what might the far future hold?
Exactly. It's like a giant thought experiment, but one grounded in real science.
So for everyone listening, our mission today is to explore this timeline and pull out the most intriguing points.
The stuff that really makes you think, whoa, I never considered that.
We'll navigate the really long stretches of time.
And try to highlight what these cosmic timelines tell us about the scale of change.
All that without getting lost in overly technical jargon.
Let's start with something relatively close. Just 1,000 years from now, around the year 3000, the moon's gravity, those tidal forces, they'll have slowed Earth's rotation just enough that we'll need to adjust our clocks a lot more often.
More leap seconds.
Way more, maybe even multiple times a month. Imagine trying to keep schedules straight with that.
It's crazy how a force we barely notice, that gentle pull from the moon, can have such big effects over time.
It adds up, little by little. And speaking of things changing in the sky, in about 1,100 years, we'll have a new North Star.
Polaris won't be the one anymore.
Nope. Because Earth wobbles a bit on its axis. It's called precession. A different star, Gamma Cephei, will take over as that guiding light in the north. It's like a slow cosmic changing of the guard.
Now, for something a bit closer to home, something we're actually causing right now, the timeline says that in roughly 5,000 years, the Greenland ice sheet will be completely gone.
Melted away due to the global warming we're seeing now.
Which really shows that what we do today can have consequences that last for millennia.
A sobering thought, isn't it? Our actions are shaping the planet for thousands of years to come.
Now, this is interesting that the timeline also touches on what might happen if humans were to suddenly vanish, say around 10,000 years from now.
Without us around, Earth would be in for a relatively stable warm period. But then, 10,000 years after that, we'd be due for another ice age.
A natural cycle.
Yeah, but here's the thing. The timeline says our greenhouse gas emissions might have thrown that cycle off. We could end up delaying the next ice age, maybe even making Earth skip it entirely for at least 500,000 years.
So even if we were gone, our impact would be felt for a very, very long time.
Our mark on the planet's climate would be a kind of legacy. Let's skip ahead a bit more, into the tens of thousands, even hundreds of thousands of years range.
Now we're talking. What's in store for us there?
Some potentially awesome sky shows. The timeline says that within the next, say, 10,000 to a million years, two stars we can see with the naked eye, Betelgeuse and Antares, are likely to go supernova.
Explode.
Huge explosions. We're talking brighter than the full moon, visible even in daytime for months.
Yeah.
Now, supernovas happen all the time across the universe, but to have one so close to us, that would be an incredible sight.
A once-in-a-million-years kind of event. And speaking of cosmic cycles, remember that wobble in Earth's axis we talked about? Well, in about 11,700 years, it'll put Vega, that bright star in the summer sky, right in line to be our new North Star.
Another handover. And that same wobble, that axial precession, it does more than just change our North Star. It actually messes with our seasons. About 11,000 to 15,000 years in the future, Earth's tilt will be, flipped compared to today.
Flipped.
Yeah, so summers and winters would happen on the opposite sides of our orbit. It would mean less extreme seasons in the southern hemisphere, but more extreme ones in the northern hemisphere, mostly because of where the continents are.
Okay, here's something I find really fascinating. The timeline says that about 15,000 years from now, the Sahara Desert might turn green again.
Really?
Yeah, that shifting tilt we just talked about, it would move the North African monsoon northward. So the Sahara could become a tropical region again, much like it was thousands of years ago.
Hmm.
It makes you wonder how that would change things for life, for people, if we're still around.
Huge shifts, for sure. Climate really does change everything over long timescales.
And while the Sahara is turning lush, the timeline suggests that in about 50,000 years, our current warm period might end, and we'll slide back into another glacial period of this ice age.
A return of the glaciers. Though, once again, our actions today might mess with that.
Right, that climate change effect could delay or even completely skip that next ice age, maybe for another 50,000 years. Our impact on the planet, it just keeps echoing through time.
We're becoming a force of nature, in a way.
Yeah.
And while we're thinking about long-term changes, there's a certain famous waterfall that might not be so famous in 50,000 years.
Niagara Falls.
Yep. The timeline says it'll have eroded away by then, basically disappearing as we know it.
Gone.
The falls will reach Lake Erie, so no more dramatic plunge. It's a reminder that even features that seem permanent are constantly changing.
Speaking of things disappearing, the timeline also mentions those beautiful glacial lakes in the Canadian Shield. They're expected to be gone around the same time, worn away by post-glacial rebound and erosion.
Another example of how the landscape we see is just a temporary snapshot.
A moment in time. Now let's jump to 100,000 years in the future. By then, the stars themselves will have moved enough to change how the night sky looks.
You mean the constellations?
Yeah, they'll be completely different. Those patterns we've used for navigation, for storytelling, for thousands of years, gone. All those stars are drifting through space, just very slowly from our perspective.
It's hard to picture, isn't it? The sky itself rearranging over time.
It makes you realize nothing is truly static. And here's something else that might happen around this time, or maybe within the next 10 million years. Two of Uranus's moons, Cupid and Belinda, are on a collision course.
A cosmic crash. It shows that even in places that seem calm and predictable, like our solar system, there can be these dramatic events unfolding.
Back on Earth, though, something new might be forming. An island.
An island.
Yeah, the timeline says that in roughly 250,000 years, a volcano in Hawaii, Kamuakanaloa, will finally break the surface of the ocean. A brand new island will be born.
That's plate tectonics at work. Building new land. Incredible.
But there's also a potential danger lurking out there. An asteroid impact. The timeline says there's a good chance Earth will be hit by a kilometer-wide asteroid in about 500,000 years. Unless, of course, we figure out how to deflect these things.
Planetary defense. Something to think about for the very long term.
All right, let's really fast forward now. 50 million years into the future.
Wow. What does Earth look like then?
Well, according to the timeline, the San Andreas Fault will have kept shifting, so much so that the Gulf of California will have basically extended north, flooding the California Central Valley. It would create a new inland sea, with Los Angeles and San Francisco practically merging.
A completely reshaped coastline.
Mm.
And speaking of changing continents, the collision between Africa and Eurasia, which is happening very slowly right now, will be in full swing. The Mediterranean Sea will be gone, replaced by a giant mountain range like the Himalayas, but even bigger.
And what about those mountains we know today? The timeline says the Appalachians, for example, will be mostly eroded away in 50 million years.
Worn down over time. Though, interestingly, the overall elevation of that region might actually increase as the valleys get deeper.
So even as mountains shrink, they can change the landscape. Now let's check in on the sun. In 110 million years, it will have gotten about 1% brighter. Doesn't sound like a lot, but over these vast timescales.
Those small changes add up. The sun is gradually getting hotter as it ages, and that has big implications for Earth's climate.
Exactly. It's a slow burn, but it's happening. Okay, another big jump forward. 600 million years from now, what's on the agenda?
Something a bit sad, actually. The timeline says that by this point, the moon will have drifted so far away from Earth that total solar eclipses won't happen anymore.
No more eclipses.
Nope, that incredible alignment where the moon perfectly blocks out the sun,
Yeah.
it'll be gone. That slow drift caused by tidal forces, it'll change things forever.
A loss for future skywatchers, for sure. And this is where we start to enter territory where life on Earth might be in serious trouble. Around 500 to 600 million years from now, the sun's increasing brightness is predicted to start disrupting how our planet handles carbon dioxide.
Too much heat for the normal balance to work.
Right. It'll mess with something called the carbonate-silicate cycle. This could lead to carbon dioxide levels dropping so low that most plants won't be able to survive. We're talking like 99% of plant species going extinct.
Wow, a mass extinction. And plants, they're kind of important for everything else. But hold on, the timeline also mentions a more recent study from 2024, which suggests that maybe this process, the silicate weathering, might not be as sensitive to temperature changes as we thought.
So a bit of hope?
Maybe. It could mean Earth's biosphere, all the life on the planet, could hang on a bit longer than we originally thought. But even so, the long-term trend is still there. A hotter sun, less carbon dioxide. It's not looking good for plants in the far future.
And the timeline goes on to describe how things get even worse. As Earth heats up and carbon dioxide keeps dropping, around 800 to 900 million years out, it might reach a point where even those plants that have adapted to hot, dry conditions can't survive.
So no more plants at all.
It's looking that way. And without plants to replenish it, the oxygen in our atmosphere would start to disappear. No more ozone layer either, so harmful ultraviolet radiation from the sun would reach the surface.
That's bad news for, well, pretty much everything.
Right, land animals would be the first to go. The timeline suggests that some ocean life might hold out a bit longer, but eventually, all complex life, the kind we're familiar with, is predicted to be gone. Earth would become a very different, very harsh place.
A bleak future. And then, around 1.1 billion years from now, the timeline describes what's called a moist greenhouse effect. Basically, the sun will be so hot that the oceans will start to evaporate uncontrollably.
The ocean's boiling away.
Basically.
Yeah.
And that would likely shut down plate tectonics completely, if it hasn't already stopped by then for other reasons. Earth would be a much more geologically quiet place.
And a much drier one. So no more oceans, no more plate tectonics. What happens to life?
Well, some simple life forms might cling to existence in whatever pockets of water are left, maybe at the poles. The timeline says that even eukaryotic life, which includes all plants, animals, and fungi, might be completely gone by about 1.3 billion years from now.
Only the simplest organisms left, and even they have an expiration date. By 1.6 billion years out, the timeline suggests that all life on Earth could be extinct.
A completely sterilized planet. It's a stark reminder that a planet's ability to support life depends entirely on its star.
And on that note, let's talk about our sun's eventual fate. In about 5.4 billion years, it's going to start turning into a red giant.
That's when it runs out of hydrogen fuel in its core.
Right. It'll start burning helium instead, which makes the sun swell up enormously. It'll probably engulf Mercury and Venus.
And Earth.
That's the big question. The timeline gives a specific time, about 7.59 billion years from now, when Earth and the Moon are very likely to be destroyed.
Falling into the dying sun. It's a dramatic end to our little corner of the cosmos.
But even before that final plunge, things could get pretty wild. The timeline says that the Moon might actually spiral inward, getting so close to Earth that it breaks apart due to tidal forces.
Torn apart by gravity. We'd end up with a ring of debris around Earth, most of which would eventually rain down on the planet.
Quite a light show, though I wouldn't want to be around to see it. But the timeline doesn't stop there. Even after the sun sheds its outer layers and becomes a white dwarf, a much smaller, dimmer star, the story of the universe continues.
The far, far future.
The timeline even mentions the Big Rip scenario, where the expansion of the universe gets so extreme that it rips apart all matter, even atoms themselves. This is predicted to happen around 22.3 billion years from now, but only if a certain model of dark energy is correct.
Right, and that model isn't really supported by what we're seeing in the universe. Dark energy is still a huge mystery. We don't know how it'll behave in the very long term.
So the Big Rip is still a possibility, but not the most likely one. Instead, the universe might just keep expanding and cooling down, becoming a much quieter, emptier place. And as we get into the truly mind-boggling timescales, trillions and quadrillions of years, well, even stars eventually die out.
Galaxies would run out of the fuel they need to make new stars.
And the stars that already exist would either fade away or get slung out of their galaxies.
Eventually, even the white dwarfs, like what our sun will become, would cool down to almost absolute zero.
The universe would be dark and cold, filled mostly with dead stars and black holes. And then if a certain theory in particle physics is correct, things get even weirder.
You mean proton decay?
Exactly. If protons, those tiny particles that make up atoms, aren't actually stable if they eventually decay, then all matter as we know it will eventually cease to exist. Even black holes would slowly evaporate over unimaginable stretches of time.
Leaving behind an almost perfectly empty universe. It's hard to even comprehend timescales that long.
It really is. So let's just pause here for a moment and appreciate the sheer scale of what we've just explored. From changes we'll see in the next few thousand years to the potential end of matter itself, this timeline really puts things into perspective.
Thinking back on it, I'm struck by how many surprising things are in store. Uranus's moons colliding, the Sahara becoming a tropical paradise again, the end of total solar eclipses. It's all a consequence of basic physical processes playing out over vast stretches of time.
And then there are those more extreme scenarios, like the Big Rip or the slow evaporation of black holes. They challenge our understanding of reality itself. So to everyone listening, we hope this deep dive into the far future has been enlightening. Even though we're dealing with possibilities, not certainties, learning about these predictions and the science behind them, well, it gives us a deeper appreciation for how the universe works.
It connects us to those fundamental processes that are shaping everything, right now and for billions of years to come.
It really does. And as we wrap up, we want to leave you with something to ponder. How does knowing about these potential futures, even if they're incredibly distant, change how you view the present? Does it make you think differently about the choices we make today, about the legacy we'll leave behind? What does it mean to live in a universe with such a long, potentially dramatic future ahead of it?
It's a lot to think about.
Yeah.
But that's what we do here on The Deep Dive. We explore the biggest questions, the most mind-bending possibilities, and today we've certainly taken a deep dive into the very long term.
That we have.
Thanks for listening.
And keep those suggestions coming for future deep dives. You never know where we'll end up next.